Quadrilaterals review, number 15, third video. So let's see, equiangular, but the quadrilateral that is equiangular but not equilateral. So that throws out the square and the rhombus. Equiangular parallelograms don't have to be, so you're looking at choice 1, a rectangle. Okay, so that's the answer to 15. Quadrilateral that's not a parallelogram. So this one's where this is a little bit tricky. A rectangle is, a rhombus is, a square is, a trapezoid might not have to be a parallelogram. Okay, so if it just has one pair of opposite sides parallel, which a trapezoid can have, it's not quite upgraded to a parallelogram. All right, some more properties. Hopefully these are quick. An example of a quadrilateral, number 17, whose diagonals are congruent but do not bisect each other. Good question. This is typically a trick question. The congruent leads you to square or rectangle. But as soon as the diagonals do not bisect each other, that throws out all of those, because those all have to. An isosceles trapezoid can have congruent, or does have congruent diagonals, but they might not bisect each other. All right, not necessarily have, okay, so these do not have to. A square does, an isosceles trapezoid does, a rectangle does. A rhombus might not. Basically, you can look at it like this. Clearly, the distance from A to C is definitely less than from B to D, so the diagonals are not congruent. All right, did I skip one? Yeah. Which quadrilateral must have perpendicular diagonals? We definitely need that on a rhombus or a kite. Kite's not a choice, or a square, but so that's the one there. Which statement is not always true for A? I believe they mean parallelogram here, so let's assume they do. Okay. Hopefully they won't use this symbol anymore. This might be an old one. So which is not always true? So opposite sides are, opposite angles are. So let's get rid of those. Consecutive angles are supplementary. That is true for all parallelograms. The diagonals don't have to be perpendicular, though. That's kite and rhombus. Some parallelograms are not upgraded to rhombus, though. Opposite angles of an isosceles trapezoid. Opposite angles. This one's a little trick. They have to be supplementary. Here, let's draw it out. So here you have an isosceles trapezoid, and we'll make up a number for this angle, 70 degrees. The moment you know that in an isosceles trapezoid, that's 70, 110, 110. So if you look, opposite angles happen to add to 180. A little bit tricky. Okay, I assume this means parallelogram again, that symbol. Okay. All right. So what's going to happen here is we've got at least a parallelogram, and it's ABCD intersect. Okay, diagonals intersect at E. Let's try to draw that. Is AED always isosceles? That's only if it's a rectangle. Okay, so we don't know for sure if it is. All right, so we'll cross that out. ABD. ABD is a right triangle, ABD. There's no guarantee there. Okay, I don't think that ever has to happen. AEB is congruent to AED. That's going to happen in a rhombus, but we don't have that here. This is a rhombus property. This one's still stumping me. I don't know what that has to be ever. So, yeah, choice 2 is strange. But 1 and 3, they're upgraded parallelograms. They don't need to happen. ABC, that's this half, and CDA, those do have to be. So what you're looking at is, let's say we get rid of those. These two triangles are what the choice 4 is talking about. Those do have to be congruent. So that's the one. All right, we'll keep going. ABCD is a square, okay, which is not true. Is BD the same as AB? No, BD can't be. It's the hypotenuse. BD is the hypotenuse in this, and that's a leg. So those can't be. It's going to be this one. The other ones are all going to work, though. 1 and 2 are both 45s. Okay, 2 and 3. Yeah, they're both 45s. Angles 1 and 3. They're both 45s. So, yes, it's choice 1. All right, keep going. It's going pretty quick here. All right, rhombus PQRS. That means all the sides are the same. And then MPQ is 32. Okay. Now we can blow this up a little bit just so we can see it a little bit easier. Okay, if that top half's 32, then this one's 64. Okay, because that's 32 times 2. 180 minus 64, that's going to get us 116. So we're getting some more information that we might use. Just breaking the problem down makes it a little bit easier. These angles in the middle are definitely right angles. And then the last thing, half of 116 is 58. That could be useful up in this corner. Okay, so MPS is the same. Remember, the diagonals bisect the angles. So then that's what we get, where we get the other 32 from. PMQ, that's a right angle. They're talking about this one in the middle, PMQ. QRM, if you follow that path. This is the weird situation that's not a parallelogram. Or it is a parallelogram, I'm sorry. It's got upgraded features. So this 32 would be the same as that one because of alternate interior angles. They're all the same, though, in a rhombus. Okay. Now, Q to P to S, we talked about that. That's 60. That's the 64. Okay. P to Q to R. So that's the big one. We're talking 116 there. All right. Good enough on that one. Rhombus. Okay, now they want, this is a very common question. They're talking about the diagonals of the rhombus. Remember this one. So if they give us the diagonals, what we're supposed to do with those is cut them in half. So the 30 goes to 15 and 15. The 16 goes to 8 and 8. And that's always a right angle in a rhombus. So the perimeter is going to be calculated by taking care of this one right triangle. Sorry, that one's pretty bad, but let's just get x. So you're going to do 8 squared plus 15 squared equals x squared. If you've memorized it, you know it's 17. If not, we can work it out quick. So that side is 17, but then there's 4 of them. So the whole perimeter is 4 of those 17s, or 68. Okay. Let's at least do this one more. Okay, it's going to take a little bit of work, so we're back to more involved questions, but that's good. So, quadrilateral. We want to show that it is a rhombus, so we're going to end up calculating length of every side, probably. That's our best bet. Okay. So that's what we're looking at. All right, we're going to have to, sorry, I wish I had my straight edge, but we'll just do the best we can here. Don't have a straight edge tool for this, so a little challenging. All right, so what I would do is I would calculate the length of every side by using, I use Pythagorean theorem. All right, there is a formula, but I'm going to use Pythagorean theorem. All right, so I'm going to tell the person that's grading what I'm doing. It's going to get me a little bit more credibility there. Let's go label these. All right, so we'll start with JA. It's going to be the change in x is 4. right? So we got 4 squared plus 1 squared. Call it D right here. So then we get 17. All right. Now this is, so JA is going to have a length that's the square root of 17. Now we know that they all use the same lengths, the exact same numbers and everything. But let's just kind of play the game and make sure we get all our credit. So we're going to go through it, and we're just going to really hustle through there. And I can shortcut at this point. You know, you can kind of say, okay, it's going to work out the same way, but we at least, you know, went through the process. So CK, again, you're using the same numbers. Let's just do one more step, and then dot, dot, dot. CK is square root of 17. Last one, KJ. 17 again. So KJ is 17. All right. The other information we're going to need to make sure it's not a square is we're going to need the slopes, and it's going to be a little bit tricky. Okay. I'm going to use slopes anyway. So the slopes of consecutive sides, I'm just going to take JA. Okay, so J to A is a run of 4 and a rise of 1, and it's positive, meaning it's going up, okay, as we go left to right. And let's see, AC's slope. This is going to be a rise of 4, a run of 1, and it's still positive, okay? Those are not negative reciprocals, so it's not going to make a right angle, and that's going to be what I talk about. So this is all my evidence. Okay, that's gathering my evidence. On these kinds of proofs, they don't tell us anything. We got to get it ourselves. So there's our evidence. Now we got to draw our conclusions. Okay, what am I going to say? Well, real simple. JA is congruent to AC. It's congruent to CK, and it's congruent to KJ. Because there, and this is the key word here, you got to say their lengths. The key word here is their lengths or their distances are all equal. All right, that's going to make it a rhombus. And this is your summary. So we're going to say all 4 sides are congruent. And there it is. All right, that gets us the rhombus. Next, we're going to say why it's not a square. Well, we calculated the slopes, so I can say JA is not perpendicular to AC, and that's because their slopes are not negative reciprocals. They're reciprocals, but they're not negative reciprocals. That's kind of your, again, that's a conclusion from our evidence up here, the slopes. Now we're going to summarize what that does for us. Okay, JACK is not a square. Because angle A is not a right angle. Now somebody's going to argue with me that I forgot something there. I kind of did. I'm going to make up for it right now, though. JA was not perpendicular to AC. Okay, that's why it's not a right angle. All right, I'm going to finish this video here, and we'll do some more on the next one.